All right, so we're going to look at problems related to acid-base chemistry today. And we need to really start our discussion about talking about water. So let's say I have a beaker of water. So in my beaker of water, water molecules are going to react with each other. And I'm going to write this as HOH instead of H2O. And this way we can clearly see that I have a hydrogen ion, which we associate with being an acid ion. And I have a hydroxide ion, which we associate with being a base ion. So one of my water molecules is going to act as the acid, and one of my water molecules are going to act as the base. And according to my definition of Bronsted-Lowry, the acid is a proton donor. So this acid is going to give a hydrogen to this water molecule. And so what I have left then is this OH, which is hydroxide. And this water molecule gains a hydrogen, so now I have 3 H3O plus, which we should recognize as hydronium. And so for this equilibrium, we can write an equilibrium expression, but in this case we call it Kw. So this is the autoionization of water. And so we have products, which is my hydroxide ion, times my hydronium ion. And my reactants are both pure liquids, so we should know they're not part of our expression. And Kw, just like all the other Ks, is a constant, so it has a value of 1 times 10 to the negative 14th. Okay, so you need to memorize the Kw expression, and we're going to actually use it throughout our acid-base discussion. So we're not even talking just acids and bases in chapter 14, but chapter 15 also. Okay. Now, Kw is important because this means that if I know hydroxide concentration, then I can use Kw to find hydronium. Or if I know hydronium, I can use it to find hydroxide. And the amount of hydronium and hydroxide also gives us an indicator if we have an acid, base, or a neutral system. So if I have pure water, the hydroxide concentration and the hydronium ion concentration are going to be equal to each other. And they would have to be equal to 1 times 10 to the negative 7th molar in order for Kw to be 1 times 10 to the negative 14th. And so when hydronium and hydroxide are both equal to that value, you have a neutral solution. If my hydroxide ion concentration is greater than my hydronium ion concentration, we would expect this to be basic because, again, hydronium is the base ion. And if my hydroxide ion concentration is smaller than my hydronium, we know the hydronium ion is the acid ion, we would expect our solution to be acidic. So that's one way we can tell if we have an acid or a base or a neutral solution. Another is to use the pH scale. Okay. All right, so let's talk a little bit about the pH scale. pH is just a numerical value. It goes from 0 to 14. It's a log scale, and we should know that log means it's based on powers of 10. And to find the pH, we take the negative log of your hydronium ion concentration or hydrogen ion. We should know those are interchangeable. Okay, so if this is my line, this is 0, this is 14, halfway would be 7. Okay, so we should know that if I have a pH of 7, this is neutral. If I have anything less than 7, it is acidic. And if I have anything greater than 7, it is basic on my pH scale. Okay. All right, now remember that this is based upon powers of 10. So if I change by one value on the pH scale, this is actually a 10-fold change in concentration. Okay. And so if I'm moving from a pH of 1 to a pH of 2, my concentration is decreasing by a power of 10. So that means the lower the number on the pH scale, the more acidic it is. All right, now I also want to mention that when you're using logarithms, it has its own sig fig rule. So let's talk a little bit about sig figs here. Okay. So let's say I have a hydrogen ion concentration of 1 times 10 to the negative 9th. And we take the pH of that. And we're going to get 9.00. So here's the rule. However many sig figs are in your concentration, that's how many decimal places go in your pH, and vice versa. So if my pH has 2 decimal places, my concentration should have 2 sig figs. Okay, so let's look at a problem before I assign your homework. So if you would turn to chapter 14, which is on page 598A, we're going to do number 54, and we're only going to do solution A. And that's so we can look at some rearrangement of the equations. And you probably want to have out your calculator. Okay. So in number 54A, it gives me the pH. And so we can actually find the hydrogen or hydronium ion concentration if I'm given the pH. And all I'm doing is rearranging the equation. So remember that you have this negative sign. So there's my negative sign. Log is based on powers of 10. So there's my power of 10. So if we take 10 to the negative pH, this is going to give me my hydrogen ion. So we're going to take 10 to the negative 9.63. And you can solve this a couple ways in your calculator. So you can use 10 and the caret with the negative 9.63, or the second function of your log would be 10 to the x. So you could hit that button and then negative 9.63. Okay, so if you want to pause the video and plug in your calculator and chug out an answer. And when you're ready, just hit the play button. Okay, so you should have an answer. Remember that this has 2 decimal places, so this means my concentration has to have 2 sig figs. So I get 2.3 times 10 to the negative 10th. And pH doesn't have a unit, but concentration we know does. It is molarity. All right. So now that I know hydrogen, we can actually use Kw to find the hydroxide ion concentration. Okay, and we should know that Kw is 1 times 10 to the negative 14th. My hydrogen is 2.3 times 10 to the negative 10th. And we're going to find hydroxide. All right, so again, if you want to pause the video and chug out an answer and hit resume when you're ready. All right, so we should have an answer. If I look, both Kw and my hydrogen ion concentration have 2 sig figs, so my hydronium should. You should have 4.3 times 10 to the negative 5th, and its concentration, so it should have units of molarity. Okay, and then the last part that we want to know is we want to know the pOH. So here's the other equation we need to discuss. So if I take a pH and I add the pOH, it should equal the maximum value on the scale, which is 14.00. So if I want to know pOH, we're going to take 14 and subtract from that the pH it gave me in the equation, which is 9.63. And remember, when we're talking addition and subtraction, we look at decimal places. So both 14 and 9.63 have 2 decimal places. So my POH should have 2. So we get 4.37. And then the last thing I want to know is this acidic, basic, or neutral. So if I'm looking based upon my pH is greater than 7. So we would say that this is a basic solution.